cavalgar por toda a noite.
I'm in the beautiful city of Geneva. Today I'm having a meeting in the Kempinski Hotel. The Kempinski Hotel is based at the lake in Geneva. So I'm staying in the Ibis Hotel. That hotel is just around the corner. This is actually the area where the hotel is located. In Amsterdam we would call this the red light district. A 5-minute walk. So that means for the next few days, every morning I have a 5-minute walk. That's good. It's some fresh air. It's about 1 or just below 0, and time to go inside. There's the lake, and there's the Kempinski Hotel. Okay, got it. First floor, just near the elevator. That should be easy, but it's very, very quiet here. So I see some activity over here. It's not really busy this morning, actually. This is the first morning. This afternoon we're going to have a trip to CERN. I'm going to tell you all about it later. This morning, this is a workshop held by the ICCRA, the International Critical Control Room Alliance, which is part of the TCCA.
Good morning, everybody. How are we?
Yeah.
Jeff's going to talk to us Thursday,
right,
about APCO and its broadband project, broadband in the control rooms.
Absolutely wonderful to see so many people here from so many different organisations and so many different countries.
This is also the other side of the interface, is like mobile radio network vendors.
Peter Prater, just a few things. We had this morning the control room working group.
Yes.
Lots of things are going on.
Lots of things.
It's not as simple as everybody thinks, right?
It's not as simple as we all thought,
So-
but it's a great challenge that we're going to rise to.
Yeah. So what are the challenges that need to be overtaken? Because it's kind of important, right?
So first of all, I think the thing that's come out of today is that we need to map the as-is scenario across the globe for these technical standards. Every country seems to be doing some things, but not other things. Every country seems to have different ways and approaches of doing things. What we need to try and do as ICCRA is just to map the current work that's going on, and then look at the interfaces that are not being dealt with in different parts of the world.
I heard from the 3GGP that the ICCRA needs to take this on board itself, right?
Yeah, absolutely. ICCRA
That's-
needs to take this on. This is for the sake of control rooms everywhere that we get on with this work, because control rooms currently are suffering. Organisations' reputations and relationships are suffering because they can't do a lot of things that clearly they need to be able to do.
And this is all about a common standard.
All about common standards. Having common standards like we have in a lot of our life today. Certainly in the radio systems, we have a lot of standardisation, but we don't have it between our control rooms, and that's where we're letting ourselves down.
Can you imagine a place where work is being done at about 250 below 0? One of the things that we're going to see today at the CERN visit is the major control room they have in order to manage everything that's being done at CERN. It's a huge control room. Rosano is taking the lead on that. He's really so kind to invite us for that specific event. This is Rosano Giacchino. Rosano, I believe I said that right, when you're responsible for the control room at CERN, is it?
Responsible for the CERN control center. Yes.
What is CERN?
Well, CERN,
In one sentence.
well, CERN is an European research organization that is doing fundamental research in physics, and it was founded in 1954.
It's known all over the world.
Yes, mostly recently, especially for the LHC accelerator, which and the X discovery.
You showed a presentation where work is being done in temperatures minus 273 degrees, is it?
Yes, 271, yeah, which correspond to 1.9 Kelvin.
That's extremely cold. Why is
Yes.
that so necessary?
Yeah, because I mean, in order to have the LHC accelerator functioning, we have a superconducting magnet, and superconductivity can only appear when you can reach this temperature, which means that at this temperature, the coil of each magnet is less resistant.
And that all needs to be controlled and managed through a control room, and that's a huge one, is it?
Exactly. So in the early 2000s, we figured out how we can control the LHC, and given all these figures that I'm just saying now, with that they were far above any other accelerators, due mainly to the superconductivity, we thought that unifying all existing control rooms at CERN, including the technical and the cryogenic control room, were necessary, were paramount. It was very ambitious, it was a challenge, but we succeed. And I think this is contributing largely to this ultimate success of the LHC.
Well, looking forward to see the CERN complex, because it's a large complex, isn't it?
In 10 minutes we'll be there.
10 minutes. In order to understand exactly what's happening here, give you a little bit of an idea of how we as a humankind are being born and how, from what kind of particles do we exist. Let's take a look. Join me. This is a really fast one. Let's speed it up. Just to get everything a little bit in perspective, yes, I'm not in space. What I like to understand is how the control room manages all of the things that are happening right here. If you are responsible for everything that's happening here, you need to make sure the control room is working pretty damn well. What happens when something goes wrong? Because all of these particles, if they get this big boom and so much energy comes free, I'm kind of frightened a little bit.
As you will visit in a few minutes, there is a huge control room to manage all the operations at CERN. And when something starts to go wrong, it's easy to cut the beam. It takes several microseconds to cut the beams, and nothing can go really wrong.
Is it not too late then?
No. It's everything is okay. Everything is under control, and we have all the personnel and all the material to manage all the operations.
And it's very small particles, right? Yeah. That's also the good thing.
Yeah, but we are 140 meters above the Earth.
Normally, it's not allowed to go into the control room. This is a once-in-a-lifetime opportunity, as they say it. This is really unique if you're into control rooms.
So I would say that island is more near what you do, because it's phone call, is dispatching, especially for the technical infrastructure. And for the cryogenics is more industrial process, of course, which is very important for us, because otherwise the LHC would not function. What is important to see is that these are the wall screen, which are very important for us in operation, because while I'm talking to you, if you imagine I would be in charge here, I can still look with the back of my eye and see what happens. So I can still intervene into the machine. Then you have the second layer here, which is also called fixed display. So is an important information that I can still check while I'm still talking to you. The lower layer is more an interaction. So there is really where the application program are helping us. So usually there you have to sit, and you have 3 screens with a keyboard and a mouse, and you do actually change settings and you change some parameters. Indication that when we build this control room, we wanted to put everybody together. and I think that was a really important step forward. Although it was very difficult, there was a lot of reluctances. I think that this is part of the success of the LHC, to be all in the same place and being able to discuss problem together and reaction very quickly, and having the technical infrastructure and the cryogenics in the same place. I think this was vital for the LHC performance.
These are the radios they're using here. They were delivered not such a long time ago by CERN, I believe. They're still in the charger. I wonder if they have been used very much. In what kind of circumstances do you use the PMR, the Tetra? The Tetra radios. Because you work with the Tetra network here, is it?
Yes, but I mean, in the control room there is only the technical infrastructure people, which they use it, and sometimes the cryogenic people. But this system is heavily used by the firemen at CERN.
Good stuff. I am sitting in the middle of the path here in the bus. People there, people over there. Now we're going through customs, and I've just been advised that it's kind of better to go a little bit more deep into the bus and then make sure that customs doesn't see me. Not because I've not got my passport with me, but just because I was sitting in the front. Okay, let's wrap up the day. It was a very good day. There was a very large room filled up with a lot of people interested in control rooms. Not only control rooms, in about creating an environment for manufacturers to build one standard. Maybe later on with IOP processes. That is not that easy. I just realized if all of these manufacturers now get together and create one common standard interface for these control rooms, that would be a good start. So that was day number 1, critical control rooms, Geneva. It's starting to get cold right now. It's a beautiful day. ICCRA is going to be a success, no matter what.